So pivot table is always recommended, and you will see along my slides that I've created. Always I have, like, after one exercise or after one calculation, I've always been have always there will be a slide talking about data validation in pivot tables, because that's the quickest accessible thing that we have with Datorama, which basically allows us to validate our data in a glance at a, like, in a, in a fingertips, in your fingertips you have it. So it'll be easy for you to validate, and it's pretty simple because it rests above the data streams. So once you've done one, you can go ahead and do that. So what are the components of pivot tables? It has a date range, it has some filters, it has dimensions, it has measurements. So pivot tables help us view data in simplified, customizable view, and pivot table is also very necessary when we are working with calculated dimensions and measurements, because calculated dimensions and measurements are not data stream specific, but they are workspace specific calculations that happen. So whenever we are using a calculated dimension or a measurement alongside a pivot table, alongside a data stream, we always need to go and check that if my calculated dimension or measurement is working properly along with my data or not. Okay, so whenever you go to the pivot table, you see, like, my pivot table, you see the previous year, and then you see campaign name, media buy name, clicks, impressions, whatever you choose. How do you get these, and how do you validate? So you know so you get the holistic view of this in a pivot table, whatever we had in Excel. And what helps you is, in an Excel, you have the campaign name, which you filter. So suppose you want to see a view for a single campaign or something, you can put a filter in there, and you can see how things are configured with respect to all the other fields that you have updated. Okay, so create and customize. You go to your analyze and act, you go to pivot tables, you do an add new, and you can also go to the pivot table, as I was talking, like, it just rests above the data streams. So once your data stream is created, you can go into show in pivot table, and you can do it. You can customize your dates. You can choose your dimensions. Here it is selected as dates, and then you can choose your measurements as is. So you have the checkboxes of show column total, show rows total, exactly the same way we have it in the Excel pivot table, right? Whenever we do a classic pivot table, and then we want not, like, we don't want our row total or column total to come up and stuff. So we make those, and then if you work towards the advanced of it, we call it as a power pivot, and in power pivot we do these changes. So exactly the way, a normal pivot table works, you customize your dates, and then you go to add filter data stream. So yeah, so how do you add, like, there is, now that you have data in there, you can add a filter. Filter can be of any dimension that is there in your data stream, apart from date, because date is already present at the top of the page. And then you can add any of that, or any of the filters that are filterable, rather, like, it has to be filterable as well. So when I say any dimension, any filterable dimension that makes sense to you to filter and see the data can be filtered from the pivot table settings. So once you click on the add filter, you get this filter thing coming up, whereby your data stream is already selected. You can go ahead and select any of the campaigns that you want to. So when you choose campaign name, it gives you a space to enter your campaigns, and then you can go ahead and see a filtered view. Validate your data using pivot table. So yeah, again, there is this campaign name, there are clicks in the Excel, and you want to validate, if it is being aligned or not. In this example, we do see that it's 1198 was the total, and in the pivot table as well. So we can validate that it was uploaded properly. Any harmonizations that went in was for good, and it is showing up properly. It's correctly. Impressions again, if you want to choose, you can see that the impressions do match. Okay. So always name your pivot in case you want to refer the pivot for future references. The lastly, it comes as share and export a pivot. So you can go ahead and export a pivot. You can create a widget out of it. So if this view you want as a widget, it looks like this. So this is the table view, how it is. How it is, and this is the widget view. Widget is something. Widget is the components that we have for visualization, which we call it as graphs or charts. Those like those each thing, each of them are like called as widgets, and those and we can also create custom widgets, and a pivot table can also be a part of the widget. Okay, so you can create a report out of it. If you want to export this, you can create a report out of it and export. You can when you create a report, we have seen how we create reports, right? So it's the same way. You can create a report out of this, and you can choose your relevant uh, you know dimensions and measurements and all the other periodical calculations, and you can export raw. You get the raw view in Excel and stuff. So that's it. I guess it's pretty self-explanatory. Once you have access, you'll get it. And over the course of time as well, when you see me working in Datorama, you will see that I'm validating in Pivot, and it's very self-explanatory. Please, and it stays recorded in this call as well. So need not worry about pivot tables much. Okay, now we come to two very important topics in Datorama: calculated dimensions and calculated measurements. Okay, so what are calculated dimensions? How do calculated dimensions vary from classification methods? What would why, when would you use calculated dimensions, and how can you access calculated dimensions in Datorama? So, calculated dimensions. So, first we have mapping formulas, right? We have seen mapping formulas when we were adding media cost, or when we are using a coalesce function. We have seen, we have used coalesce function for media by key whenever it was two different column headers in two different formats. So we have seen how coalesce function works and how coalesce function is used during mapping. So and in that terms, like, you can go ahead and do any sorts of mapping formulas. If you want to edit your media cost, your media cost is coming, you want the media cost column to report media cost into 0.05 for your specific need, you can go and do that. So that is called a mapping formula. Then comes your classification data streams and parent child data stream. We will do parent child later. After this, we will do parent child, because once you know calculated dimensions, I feel Datorama feels parent child is comes first. But what I feel is, once you know your calculated dimensions, parent child is easy. And transformation rules or transformers. There are certain transformation rules or transformers that you can use to harmonize your data. Pretty simple stuff, but important stuff. Now your data has mapping formulas, classification data streams, transformation rules, and all sorts of things. But all these things are coming under the umbrella of calculated dimensions. Why? Because all these are specific to data streams, right? Mapping formula is specific to the certain data stream. When you are trying to map your particular raw data to the Datorama model field, in some field you feel that there is a formula needed and you go ahead and put a formula. Or so if you want to add a CPC, maybe you can go choose a field called, like, as a media by customer attribute, or um, whatever, like, from the right side, and in the left side you can have the formula of spend and clicks. But and that works, but that is data stream specific. Parent child is again a data stream specific thing, because whereby what we do is we make one stream as parent and the other as child, due to because we want some kind of harmonization to happen. Data classification, that is again a data stream level thing. Talk about what is not here, patterns. That is again a data stream specific, because you need to add data stream as a filter in your patterns to find the pattern or segregate it. Talking about transformers or transformation rules, you'll see that uh, your data stream, how it shows the data, it needs transformation of some kind, or transformers of some kind is needed, so that rows, maybe you want rows as columns, like transposition, or cross tabbing, whereby you do these things. So, but it's pretty data stream specific. Calculated dimension is workspace level. So if today you make a calculated dimension, that is, say, you have a, say, suppose you have a placement ID, or if you are aware, you guys, if you're much familiar with campaign names. So suppose your campaign name's fourth position in your campaign name tells you that the country code is present over there. Okay, the fourth position of your campaign name is country. It contains the country codes. If you extract that, that becomes an individual dimension throughout your workspace, correct? So anywhere you have this, now it depends that if it is relevant or not. Okay, now it depends that if it is relevant to the data stream or not. That is something that you need to find. If all your if all your campaigns from all your sources have the fourth position of campaign name as country, then the calculated dimension is true for entire data of your workspace. If your tagging team, or if your campaign guys have done their job correctly, then if you make one calculated dimension, it should work across. Why? Because everywhere in campaign name, fourth position, if I do an extract function, extract is one function that we use to extract some part of your dimension. And if I put, like, extract media, extract campaign name, and if I give the delimiter to be, say, 3 or 4, it'll fetch the third or fourth position, irrespective of it being used with whatever data stream, because it is at a workspace level. Everywhere you use it, it will be finding the campaign name, classifying the fourth position. That's it for you. Okay, so calculated dimensions stand as an umbrella above your data stream filters. So we will read about overarching entities. So calculated dimensions are act as an overarching entity. Even what is an overarching entity? We will take it overarching entities at a point in our session. But then overarching entities basically are placeholders that help us map any data that we want to, and connect it with the other. What I mean by that is, um, when you have a media buy or placement or campaign impression clicks, etc., in your data stream, the data stream yesterday we have seen is, the data stream type is ads data stream, correct? And then when you upload something, a data stream from your Google Analytics, say suppose, which contains web analytics site key, web analytics site source key, visits, page views, bounce rates, so on, acquisitions, so on and so forth. So when those things come in, Datorama already picks it up um, um, as web analytics data stream. Now campaign. Now I have one ads data stream and one web analytics data stream. Now somewhere I need a commonality so that I can connect my data, right? We will read it. So there comes the overarching entities, which basically allow us to connect the different types of data streams, the different types of data type uh, streams, um, into a single bucket, and helps us to join different types of data. So that is called an overarching entity. Calculated dimensions also is a type of overarching entity which lays above the data stream level, like calculations, formulas, or rules. Okay, it's workspace level. Remember this. Real-time queries that takes place throughout the workspace. Yes, definitely calculated dimensions are something which accommodates this feature whereby real-time queries can take place throughout. And also non-numerical fields present in your workspace that you can create on top of your existing data. So these are some of the workspace level things that you create above your existing data, because you need some kind of an harmonization. Why do we need it? Because calculated dimensions are flexible. When we say flexible, it is at workspace level, right? So it is not bound by any kind of different type of filtration or any type of specific filters or specific settings or specific thing that we need to do. Nothing like that happens. Also, it is flexible and easy to maintain, of course, because it is one dimension that comes up and you can go ahead and edit it. And once you edit, you know what happens is, there for the entire data stream, for the entire, like for entire data stream, for all of your data stream, this gets changed without hampering any sort of data. Applicable to all of the data in the workspace, definitely. And supports a variety of functions and logical conditions. Yes, so basically calculated dimensions are used for this purpose only, whereby we have logical conditions and functions coming in. We need to, like, we do tend to see, like, what we see that what all we need. Okay, this, I have this kind of data and I need these things more. So what we do is we do a calculated dimension and we use our logical conditions and functions to extract or to harmonize or to get that dimension that is not natively present but needs a calculation in there. It helps us with consolidation of our data. So, say, suppose you have definitely faced a situation whereby you see that your campaign category, or any of your field is not, not following the case, or not following one taxonomy level naming. You will see that some or the other, because, and it generally happens because, we have our campaign uploading teams which shuffle very, um, like, which shuffles predominantly, and each one, in a world like that, is always looking for, always looking for, um, how fast can I do the work and complete it off. So if five account managers have worked on five different sets of campaigns, which are present for the brand, you will see that there are, like, five different naming conventions. If not done correctly, five different naming conventions for the same thing that we have. And this is an example as well. Someone has written automobile, someone has written automotive, someone can write auto, and everything falls under automotives. Same for communication. We have comms, communications, communications, and all those things. But everything falls under communication. Similarly for tech. So we know, right, that this kind of a scenario can happen. So we need a process of consolidating our data into automotive communication and technology. So calculated dimension helps with this kind of an ask, whereby it helps us to culminate all the things together. Extraction. So we need, say, suppose we need another dimension from the first position of our media by name, which will help us to do some kind of an analysis. We see, like, high gear or automotive analysis, car world. uh, Maybe these as a dimension will make much more sense with my measurement, and I want it as a single measurement which comes from the media by name. Um, calculated dimensions come into being, and it helps us do that. Classification. Now, if you have your web analytics site source, which comes with something called Yandex, Yahoo, Twitter, Instagram, Google, etc., and you want to classify your data into, say, search, social, display, etc. Over here, it's search and social only. So, search and social. Calculated dimension helps us with doing these kind of work. So let's look at a logical condition that we have used an if and a lower, and let's see what case, what is the use case in which we are doing it. Simultaneously, we will see this in Datorama as well. So here we will see, like, how to use an if logical operator in a calculated dimension along with a lower text function, and why do we need it as well. So we have this, right. We have the campaign category automobile and automotive, which belong to the same campaign category, right? So what we do is we go to calculated dimensions, we create a calculated dimension, and then use the calculated dimension uh, to get my set of um, get the set of things that I want. So campaign category needs to be uniform. So what we do is we go to the expression box and we go to if, and Datorama's quick tip function is awesome because it whenever you have selected one function from the list, um, what it does is in the below field it gives the definition for it. So when you see the data over here, you see some are in caps, some are in small, some have capital A's, and some don't have. So what you need to do is you need to harmonize. So what I want is all my data to be converted to a lower. Lower is nothing but a lower case, and using it along with if. So what I'll do, I'll choose if and then lower. And what I want to classify is campaign category, right? So I'll do an if, and then campaign category contains automo. So what it will do is it will from this list find all the fields that contain automo. And what do you want it to do? You want it to throw automotive. So what will happen is it will go and check, first convert and then check the campaign category. If it contains automo, it will convert it into automotive. Similarly, um, Similarly, if you go and check, like, after that, if campaign category contains com, then communication. If campaign category contains tech, then technology. Else, always if is always tagged with an else. So else is lower campaign category. Let's return campaign category if nothing matches along the line. So how do we do that? We go to dimensions, we go to calculated dimensions. Okay, and choose this. So in my file, I have kept like two things. So how it looks like basically. Wait, I think I created a pivot for you. Hmm. So how it looks like in the data stream is technology, technological, techno, automotive, automotive, automob, auto coming up, right? So what we do, we know that what I need to do is I need to classify my campaign category, right? And so what happens is you go to you select campaign category. There is a pane which lets you select the type, which is text over here, and there is something called a related measurement. Related measurement, I'll show you what is a related measurement, but just to keep in mind, related measurement is nothing but it adds context to your calculation. Okay, so if I have, say, suppose I put the related measurement to be campaign key, what will happen is it will compute keeping campaign key as a context for its calculation, and per campaign key it will do its calculation. This is a dimension thing, but if it is involving any sort of measurement that needs to be sliced and diced, so a contextual measurement helps us with that functionality, and any contextual um, thing will be like will be helpful in case we want to do. We can add a contextual measurement which will be related, and the date calculation will happen keeping this context in mind. Okay, so what do you do? So the best part is you can go over here, and if you're doing an if, so you can choose this from here, and if you just click on if, you will see that in below it tells you what this function does for you, and you can just drag it off in there, and you can write the function. So if, and then I want like all my data to be normalized. So to normalize, I'll use a lower function, and then campaign category contains auto, then automotive. If campaign contains com, then communication. If campaign category contains tech, then technology. Else campaign category. Simple function, right? So how does it help us? This is before without uniformity, which gives me a total of 8366. And this is after it gets uniform, right? This is basically the calculated dimension that I have used over here in order to get the data, and I see that it works perfectly for me. So technology and automotive, which gives me this data, which was previously scrambled around like anything, but the data is correct. Okay. So yeah, so this was the first example that we see, and once we are done with it, we like before it was spread all across, right? But when you categorize and when you do a uniform thing, this gets uniform and this gets categorized accordingly. Make sense? Cool.
Yes.
The second is extraction. So like I'm sure people are familiar with the extract function. So what we do is we create new dimensions based on existing dimension values. So what we do is we Over here, from our existing dimensional values, we use the extract text function, and we extract some parts of the data which we think is relevant to us. Okay. So now you have your media by name, which has like uh, delimited values in it, which basically has some meaning, right? High gear, VWW, and everything has a meaning to it, and everything is relevant to a single dimension, which is relevant to a single column over here. So what you can do is you can go ahead and um, you know you have this delimited values. So there is the one function called extract, and your motive is to extract the first position of your media by name, so that this first position of your media by name can be a single publisher, can be a single dimension altogether when you extract it, and you can use it for your various calculations and stuffs. Okay, so pretty simple function is extract media by name, and you put put the delimited place, which is underscores, because we all have we have underscores over here, right? So what you do is underscores and comma 0. Okay. So why 0? Because in Datorama the indexing begins from 0. So it is 0, 1, 2, 3, 4, right? So the first position is referred to as index number 0, which basically what it does is it extracts your first position of media by name and helps you do it. So that's pretty self-explanatory, and once you have that out, you can use it as part of any filter, any horizontal graphs or anything. So this is pretty clear, right? Yeah. So what I've done is I've gone to my calculated dimensions. I have added something called channel extract, and chosen the relative measurement as impressions, because what I want is this to dice the publisher, or the to dice the channel names or source names by impressions, so that we have each row of impression can be classified, it can be sliced using the extract function. If you don't use related measurement also, that is fine, but just to add context to our calculation, what we do is we add a related measurement. So what we have used is extract media by name and have an underscore comma 0, which basically extract the first position. Likewise, if you see this example over here, we have the media by name and we have the channel extract. So this was the channel extract dimension that I've created. And when I drag it over here, what it does is it basically pulls up the first delimited value along with the impressions over here. So now, using the publisher and using the channel extracted channels and impressions, what we can do is we can go ahead and create graphs and all, which were previously not there because it was a part of the media by key. We are doing what we are doing is we are going to dimensions and we are creating calculated dimensions. And what you can do is you can do an add new, and you put a name, you choose the way how you want it to be, you write the expression, you find the functions over here, the number functions, text functions, etc. You write the expression over here, you just go and save it. When you are when you are building a table, or when you want to see data with respect to the calculated dimension, what you have to do is you have to just go over here, and in your data you can just pull it off. You don't need to map it separately or anything. Mapping is only restricted to data streams. This is not a data stream, this is a dimension that you are pulling to refer some calculation that you have done, and to see how the calculated column is giving you data, keeping in like with aligned to the native columns that come up. And the last example that I have for calculated dimension is classification. So classification is pretty simple again. And if you want to classify your data, what you can do is you can use the if statements and you can do it. So web analytics site source, if you have, which contains Yandex, Yahoo, Twitter, Instagram, etc. And if you like, the web analytics data that exist in several data streams. We just want to group these components of the column. We want to group these by not tampering the tampering the data stream. Anything, we don't want to tamper anything. Just want we want to group the site sources. So what we do is we have the search engine and we have the social stuffs over here as well. So what we want is to uh, like Yandex, Yahoo, Google, Bing to be part of the type search engine, and then Facebook, Instagram, and Twitter to be part of the social data stream. So what do you do? Again, pretty simple stuff. Um, we use the if condition whereby we say that if web analytics site source contains Google, so or web analytics site source contains Yahoo, or web analytics site source contains Bing, or web analytics site source contains Yandex, then it is part of search engine. And if it is Instagram, Facebook, and Twitter, then it's social. And if it is nothing, then return other. Okay. So what it does is it basically helps us to classify those Facebook, Twitter, Instagrams into social, and then web, like the search part to be search engine, and we can see a group data of visits, time on site, and website transactions, etc. Correct. So calculated dimensions help us to group these data, and these can be used in several graphs. We can now have source type is social and search, and we can see the various types of and we can use that custom dimension that we have just now created along with the existing measurements in our data, and we can have the relevant graphs. Okay, so what we have learned is calculated the like this is just three examples. There can be lakhs of examples for calculated dimension, but I thought like take let's take three types of work that we can do in calculated dimensions. Namely, what we have seen is consolidation, whereby normalizing my data and having a consolidated view, extraction, and lastly, what we have is classifications that we can do with calculated dimensions. Always remember calculated dimensions are workspace level metrics, and it works at workspace level. It doesn't need any mapping or anything. It can be used along with your native data and a certain level of calculation that you per se that if I do this calculation it will help me do some things. Or if you see that your needed metric, I've seen a lot of times in my project that fifth position in media by key is giving me something which is changing the entire scenario, because it is getting it is this it is the actual placement key or something. So media by key is different, and then when you have your ad server placement IDs coming in, say suppose when we do media cost center, which is we are not doing as part of this training, we are just taking an overview. But then in media cost center, if we have like what we need to do is we need to compare we can do plan versus actuals, which helps us keep track of the entire business. In that position, we have seen that in media by key, we do have this ad server placement IDs coming up. Ad server placement IDs from Delivered and ad server placement IDs from Prisma helps us basically map the placement in which our ads were displayed. So many a times I've seen that, specific to my company or other companies, what they do is they do tend to, like, in the delivered data as well, somewhere they want to culminate the ad server placement IDs. So many a times while mapping data, we have, like, the fifth or sixth position has a data which when we look up with our Prisma data, we have seen that, this is exactly the same IDs that we were looking for. And using a calculated dimension, we have fetched out all those information and we have mapped data at some level. That is not the end goal, but then at some level, we did get something, and then some other solution worked for us. But then, it can be used in such scenarios to derive a custom dimension for myself and get things rolling. So, there is something called a light connect as well with us. As we have total connect, we have light connect. Light connect is, as the name suggests, is a bit light and it's not that grave. It gives us quick and easy results. Um, and what you can do is, it's a very pretty simple kind of a tool which helps us with, if I browse my data and if I choose something like this, right? So what Light Connect helps us with is, right, Light Connect helps us create a data stream in which, like, I can go and directly edit this. Like, it what it does, what Total Connect does is, Total Connect brings my data and Total Connect tells me that, do you want to do some kind of filtration, you do want to do some kind of a technical stuff, you can do. But Light Connect is something which helps me, if I want to edit the data stream as well, I can do it. So there is something called an add field. So if you go and add a field, it tells you what do you want to add. So you can add a dimension, you can add a measurement. And if you just add a dimension in here, what you need to do is you need to type any of the conditions or anything. Like, you can write, if, say, suppose in your new column, I don't have a campaign or I don't have a relative thing, but if you want this column to basically write something, where you name this column and say you write, say your campaign has summer and winter, and you want that to be, or you mentioned country, yeah, so you can write that if, my campaign, if CSV campaign contains country in there, then what is it? You can define a country, or like, return. Say, suppose if CSV campaign contains summer, then return summer. CSV campaign contains winter, then return winter, or CSV campaign contains India, then return India. And what it does is it creates a new column for you, whereby you can just have your extracted feature, and it acts as a new column, but based on operations and functions. If you want any specific examples for me to create for you, what I'll do is I can create one and showcase it to you, by having the campaign data and all those things, so that, it is helpful for you to understand. But it's pretty simple stuff, dude. It's like, just create a new column, and likewise, if you want to create a new measurement, you can just go ahead and choose a measurement, and it gets added up here. And then when you create it, it acts as a data stream that you have created for yourself. Okay. I'll take, like, this is a very simple data set. I don't know how, like, to reference anything from here, but then I'll choose a data set which has a campaign or something, and I'll show you how this logical function can help you build a column in here. Okay.